Okay, so let's continue with a more interesting example. Now that we've already seen what type of data structures we can use in R, that's going to facilitate the way we can explore more complex data sets than the simplest ones that we've just created regarding medical details. Now we're going to work with a real data set and try to see what types of general analysis we can carry out. So the CaBi dataset stands for a capital Bikeshare dataset. I'm sure that most of you are familiar with it. It's basically a Bikeshare system that exists in DC, and it has also some stations in Virginia and Maryland. It's basically a system that allows you to rent a bicycle, use it for a while, and return it in the same one in another bike station. And the datasets that are generated were basically put in a web page by the Capital Bikeshare company, so that researchers could play around and explore what types of trips people are used to make in the tri-state area. There's a lot of problems that can be tackled with this type of data sets. So there's people looking into where new locations should be put. There's people looking into pricing schemes. And basically, this Bikeshare system, as many others in the world, have different types of affiliations. So you have rates for tourists, you have rates for users that use it on an almost daily or weekly basis for commuting. So what are the optimal prices is another important research question. There are also, as you can imagine issues with stations that do not have any bikes, or stations that do not have any empty spaces to put your bike when you get there. So there's a lot of research trying to understand optimal ways to rebalance the distribution of bikes. There's also a lot of work trying to understand what's the economic impact. So say you put stations in areas that are, not highly developed, or areas that have low socioeconomic levels. Does it have any type of impact? Are new stores opened? Do people commute more? I mean, what's the impact of this type of initiatives, right? And in general, of course, you can also understand how is it that people move about across different regions thanks to this type of data sets. And that's going to be a very important thing to understand, because for your group projects, in which you will basically have to think of, a data set or multiple data sets that you want to use to run different analyses and come up with different database conclusions, this might be a data set of interest. And in general, there's a lot of initiatives from different city halls throughout the US and Europe too, that basically make an effort of putting open data sets out there so that people can basically explore and play with them, and maybe, who knows, come up with important policy making decisions, conclusions.
Okay, we are going to be using two types of data sets from the CaBi system. The first one is the CaBi trip history. This file contains for each line one trip, where you can see the duration of the trip, start date, the station where the trip started, and there's also other information that we won't be using about bike numbers, subscription type. And then we'll also be using CaBi station information that contains data about the address of the station, as well as the latitude and the longitude, to understand what's the specific geographic location where that station is located. There's also other information we won't be using, like number of bikes, number of empty docks, and so on. You can, browse through it if you're interested.
Right. What we're going to do basically is load that data onto R. Okay. So for the trip history data, we don't need to do anything. Basically, okay, I have that file in a directory, so let me set as working directory the directory where I have that file, so that I don't need to make anything weird to open it. Go to classes in 737, and I think it's in here. Okay, so basically now what I'm going to do is, with this command, we are saving in a variable named writes. We are reading the CSV file that we have just downloaded, okay, which is the 2012 first quarter.csv, and then very important, strings as factors. Remember, everything is assumed to be a factor, but we don't want that to be the case. Okay? So what we're doing with this command is basically, once we have downloaded all the history trips and we have saved it into a file, into a directory and into a file, basically what I've just said, we set wd, set working directory to be the directory where I have those files so that, you know, my life is easier. And then what I'm doing with the second command, with the read CSV, the trip history is in CSV format, which is comma separated values. Okay, it means that if you open it, for example, in Excel, which you can do, you will see that these are basically values separated by commas. So what we are doing here is using a function that R has that basically allows us to read a CSV format and save it as a frame. So what writes is a data frame. Okay, it's a huge data frame. That's the reason why after writing the name writes, you know, it takes a while, and you can see this with the stop sign here. It takes a while to open because it basically has all the trip history for the first quarter for 2012. Again, read CSV is a function that we need to use. This is the name of the file that we want to open. And then finally, strings as factors is really important. Make sure that you put that. What we just saw, what had just happened, is because the file is really long, it says, you know, it has omitted over 360,000 different rows, which are the number of trees that we have for the first quarter in 2012. But what you can see here, basically the first 1,000 lines. Obviously, this is not a very smart way of seeing the contents. We'll see which commands we can use. But first, I want to go over loading all the data. The second data set that we're going to load are the stations and where are they located. So similarly, we'll load that. So we create a variable named stations. And in this case, the command to load that is xml to data frame. What's that? This is another command because basically the stations file is in XML format. Okay. What we want to do is basically tell our studio that we want to load this, which is in XML format, and we want to load it as a data frame. Okay. So in this case, the file is stations, which I have also saved in my directory, and which you need to save. So it's a stations, and then again, strings as factors. So make sure, as I was saying, that you download both the stations and the writes files. You save in a directory that you know where it is, and then you try to open them or load them as data frames with these commands that we are looking into. Now, it's giving me an error because, in fact, we need to use the XML to data frame package or function, and that function is in an XML package. So sometimes when you use certain functions, you will need to either install a package or at least require to use that package. The package XML is already installed, so what you need to tell R is we are going to use functions contained in this package. Okay, so it's already loaded, and basically we can execute again the command. And what it does is that it reads all the content of stations into a data frame. Now, let's go back here. So basically, as I was saying, the functions that we have used are part of packages, and that's the reason why sometimes we need to either install them. So if require XML or library XML did not work for you, just try the command install packages XML, and once you have installed it, try requiring or library XML, and it should work. Okay. Now, as I was saying before, you want to see the contents of writes and stations because these are huge files. Obviously, just writing the name of the data structure will not work, or the data frame will not work. So there's a command named view that allows us to do that better. So let's write view writes. If you write view writes, what just happened is that it basically opens at the top left-hand side of our studio. It's going to open the data frame. Okay, I'm going to close these old ones. It's going to open the data frame, and basically what you can see here is that it has 300 and over 360 different rows, and for each row you have the duration in seconds, start date, start station with the address, end date, end station with the address. So it's exactly what we saw, okay? And you have here all the different rights, and then registered or casual is the type of subscription, okay? And we can do the same thing for stations. So you can also use the command view stations. and basically it will open here another data frame. You still have the rights one, but you will have here stations too, and it contains, you know, the ID and the address. Okay, so let's continue. So the CabiData set that we just opened has different features, right? And we can see them with the view command. So some of the features that it has are discrete data. So for example, the name of the station, the type of subscription, whether it's a casual or a subscriber, the bike number, okay? Those are all discrete data. But we can also have continuous data. So for example, the duration of the trip, the time at which the trip started or ended, those are all continuous values, okay? So with discrete data, we can ask for things like, for example, what's the most frequent value? For continuous data, we can ask for things like, for example, what's the average trip duration, for example, okay? Okay. So because we are going to do, you know, for the next 20 minutes or so, we are basically going to play around with this data set. So the first thing that we want to do is actually putting it all together in one frame. What do I mean by this? So on the one hand, we have all the rights, all the information for the rights, okay? And on the other hand, we have the information for the stations. If you take a look at the rights, okay, let's go to the first column. If you take a look at the rights, basically you have, as I was saying before, you have the end station and you have the starting station, okay? And we have, but the stations are specified through an address. So for example, 7th Street and R, okay? But we don't have the latitude and the longitude for that station. So we want to basically, what we want to do is build one unique data frame that we'll have all the right information, but we'll also have for each ride next to the station, it will have the latitude and the longitude for that station. Okay, why do we want that? Because if we're going to run different research questions, like for example, we want to compute how many trips are there in the area near DuPont Circle. Okay, let's go back to the slides and let's try to understand why we need this. If we want to understand how many trips took place near DuPont Circle, we basically need to define a square around DuPont Circle by latitude and longitude, and then we can count the number of trips that happen in stations that are within that square. However, the problem is, as I was saying, that we have here all the trips, but the trips, the addresses for the stations are specified as addresses, not as latitude and longitude. So we need to extend this data frame here, the rights data frame, in such a way that it will also contain latitude and longitude for each station. Okay? Okay. So because we need to do that, okay, what we need to do, as I was saying, is basically go from the top line of duration, start date, start station, blah, 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 to the bottom line that contains the last two columns, as you can see, contain latitude and longitude, okay? So we have an address, but we also have the latitude and longitude for that address. Where it begins, where it ends. In this case, because we want to count how many trips, for example, reach DuPont Circle, we can count how many times the ending station falls within the square of DuPont Circle, and for that we need the latitude and the longitude. Okay, bear in mind, I mean, this is just an example of what is it that we can do with the CabiData set. Okay, the richer the analysis, the more complex the type of manipulations we'll need to do. So in this case, what we need to do first of all is enlarge the original data frame to have latitudes and longitudes, and then we'll be able to do a lot of very interesting analysis. So bear with me through this process of enlarging the data frame. In pseudocode, okay, so before we actually say how to do it, what we need, in fact, is first of all, to the rights data frame, we're going to add two columns, one for the latitude and one for the longitude, okay? And then what we need to do is for each right that we have, each line in the right data frame, we are going to add the latitude and the longitude for the stations. Okay. However, there's a check before doing that. And the check is that the station name has to be in the station's data frame. Okay. Why do we say this? The reason why we say this is because, as we will observe afterwards, there are any time we work with real data collected in almost real time and data that is put out there in the open, the data will not be perfect. Okay, it will have glitches, it will have missing data, it will have spurious readings, and those are all things that we need to take into account before we start our analysis. Okay, so if we were to just add latitude and longitude to every single line in the rights data frame, we would see that for some stations we do not have the data, but precisely because some of the station names that we have in the rights data frame do not exist. Okay, and we'll see an example of that. Okay, so how do we translate that pseudocode into actual, code for R? So it turns out that in R, besides the command line that we've been using, okay, and by command line I mean, every time we write something like view rights or view stations, we are making use of the command line. We write one command and we execute it, okay? But we can do more complex executions, and that's it. We can create R files. Okay, and basically run them within RStudio. We can run them step by step. We can run them at once. Okay, so R, besides again this command line, allows us to use it as a programming language. Okay, if you know how to code in Java or C, you know that you can write a file that contains different commands, save that file, and then execute it. So R allows to do exactly the same thing. And similarly, it has conditionals, it has loops, and it has logical operators. Okay, so how can we actually run code that will execute the pseudocode that I explained before? The first thing that we need to do, okay, first of all is basically we said we are going to extend the rights data frame to have one extra column for the latitude and one extra column for the longitude. So in fact, what we do is that in rights, we are going to add a latitude column, okay, and that's going to be basically a column that has as many rows as rows we have in rights. And we're going to do the same thing with another column called longitude, which is going to have as many rows as rights we have here. Again, what we want to add is for each of those lines in the rights data frame, we want to add another column, two columns, latitude and longitude. Okay, so if we now view again rights, if you take a look at rights and we go to the end, we see that we have added in fact two new columns, which are the latitude column and the longitude column, which are going to contain latitude and longitude for the ending station. Okay, and then in fact, because we are going to make a lot of numerical computations and we want this to run faster, as we mentioned before, we are going to transform the data frames into matrices. So we say, okay, just take rights and define it as a matrix and name it M rights, and we are creating another called M stations, which will basically be the corresponding data structure for the data frame stations, but saved as a matrix. Okay, so we can in fact do view M rights. It will take a time, but I mean it would show us, okay, this is M rights. Okay, and it's exactly, I mean, when you say view of a matrix, you don't see the difference. It looks exactly like the data frame, but internally it's saved differently. Okay, so basically, if we want to run the code that we just mentioned, okay, what we need to do now already in code for R, the way it looks, it's something like this. Okay, so the first line, the first four, what it's doing is repeating the internal commands for all the rows in the rights matrix. Okay, and basically the first thing that it checks is whether the station that we're looking into exists as a station. As I was saying, sometimes that's not the case, so the first thing that we need to do is whether that exists or not. And once we have checked that, the next two lines, the M rights 11 and 12, what they are doing is basically adding the latitude and longitude. Okay, so what we're doing here is basically say, okay, at the latitude column, we are going to add column number 5 from the stations and column number 6 from the stations. If you look at the data structure from stations here, column 5 and 6 contain exactly the latitude and longitude. So what we are saying is, if that station exists, just go to the data frame of the stations and take the latitude and take the longitude and add it as column 11 and 12. So we are taking these two values and adding them in these two columns, latitude and longitude. Okay, that's exactly what we want to do. And that's what this code is doing. Okay, so how can we do that? So in fact, we can do this line by line. So we can cut and paste all these lines here. Okay, but we can also basically create a new file. So you can go and say, let's create a new R script. Okay, let's copy all of this and paste here. Okay, and basically, I mean, you should be writing and cutting and pasting because it would take us too long otherwise, but you should be writing this on your own to make sure that you fully understand. Okay, this is basically an R script that we've just created. It's a piece of code that's basically going to add latitude and longitude columns on the rights matrix. Okay, now what R allows us to do is either we can execute this step by step, or we can execute it overall. Okay, so if we do something like this, basically what this allows us to do is that it's executing one after the other. Okay, so it's saying da, da, da. So this is a step-by-step execution. Okay, and you can do this step by step, and you see now here the stop sign, it's basically executing everything. It's gonna take a while because it's processing all the 360,000 different rights rows that we have. Okay, but basically at the end we'll see that the rights matrix has been transformed to have these two extra columns. Besides executing it step by step, this is really interesting when we are not sure about the code, so we are going to run it line by line. Okay, but another thing is that you can run the whole code itself. Okay, basically using these commands here. Okay, and another thing that you can do is basically save this file. Okay, so if you press to this button here, you can actually save this. So you can say, okay, I want to save this as, for example, my CaBi code. Okay, and you save it as CaBi code in such a way that next time that you need to do something, okay, you'll be able to open your CaBi code and rerun again. Does it make sense? Okay. So this is exactly again as programming in any other language. The only thing is that whenever we want to do more complicated things, we need to write code. Okay. And it's not just one command line, but things start to get a little bit more convoluted. And you know, it's always better to have it in a file so that if we need to rerun it, it's always there. So it has finished, okay, because we have again here the triangle, we gained back control of the command line. So if we want to see the results, what we can do is, okay, let's see what's in mWrites. So we write, let's close the old mWrites because this is the old one. And let's open it. And what we should have in the new mWrites is basically when we go and look at the latitude and longitude columns, we should in fact have, remember that we had 1, 2, 3, 4, and so on. We now have the latitude and the longitude for each of the stations that are in each write. Okay? So this is what we've done with the CaBi code. Make sure that you fully understand this code, okay? But remember that what the CaBi code has allowed us to do is basically go from this lat long with 1, 2, 3, 4, 5, to this lat long with the real latitudes and longitudes that we have extracted from the station's data frame. Okay. So now that we have all these, one command that I haven't explained is that percentage, okay? Basically the percentage in percentage looks for values in a table. If you look, I'm sorry, I forgot to mention that, but if we go to CaBi code again, this in here, okay, what this in is saying is make sure that the station that is in writes, it's also a recognized station by the CaBi system, okay? Here I'm just showing another example. In the weather example that we explained in class 1, we wanted to look for all the entries with humidity 3 p.m. equal to 29. So what we are saying here is give me, you know, all the elements where humidity at 3 p.m. is in that value is equal to value 29. This is just another way of using it, okay? But basically, this is a command that allows us to check whether something is in a set of predefined values or is in equal to one specific value. Okay. And another thing that's important, you have observed we've done everything with matrices, right? And it took maybe 1 minute to run it and to save latitudes and longitudes. I would recommend that you run everything just with data frames, not with matrices, okay? And just try to see how long does it take. This is an important exercise, okay? Make sure you do it. Write the code, exactly the same thing, and try to see what happens. And then, of course, another exercise that you can do is the exercise that we just mentioned at the beginning. So now that we have this data frame that basically has latitude and longitude, try to count how many writes happen within a given set of coordinates. Okay, so write, it's going to be like a 4 or 5 lines of code. But basically, just go through all the write matrix and check whenever the writes are within a given square, I'm going to count +1. Okay, just do that as an exercise. If you have any issues or problems, just let me know. Okay, as I was saying before, basically, when we explore a data set, okay, there's a specific research question that we try to answer, but in fact, oftentimes there are spurious readings, there's things that are not human, there's trips that are definitely wrong, okay? And one example, and this is what I wanted to get before, the reason why we were checking whether a given station in a rights entry is in the station's dataset is because in fact there is one station, okay, that does not exist. If you check the rights data frame, there's the White House at 17th and State Place, which does not exist in the station's dataset. So if you run the code, okay, without that if condition, it will basically stop working. Okay, the code won't run till the end because it will find a station that it's not in the dataset. It won't know what latitude and longitude to associate, and it will stop executing. It will stop the execution. Okay. So this is just to say that it's very important that you make sure that you have a lot of ifs in your code to basically check for these anomalous conditions. And then, of course, as we explained in our first class, there's a lot of statistics, descriptive statistics that you can play around with, such as, for example, summary, quantiles that will give you information about the matrices that we've just created. And so if we write summary of m writes, every time you see the stop sign, it means that it's processing. Bear in mind that here we are talking about over 360,000 lines. Okay, it's a lot of data. So what you see here basically is just a summary of this data set. So in this case, you observe, for example, how many lines we have for each different bike number, or how many different times we observe this end terminal, how many different times we observe each of these addresses. Okay, so what it basically does, the summary, it takes each of the columns and counts how many times different things happen. Okay. If you look at the range command, it basically gives you the ranges, right? Like from the smallest to the largest. Interestingly, okay, the duration of the trips, there is one trip whose duration is 248,000 seconds. Okay, that's probably not right. And this is also very important, what I was saying before. Whenever for your projects you start working on a data set, the first thing that you need to make sure is that the data set is clean and is consistent. Okay, so having anomalous durations is probably something that you need to eliminate. Having anomalous stations is something that you need to eliminate. Okay, that's really, really important. So make sure that the data cleansing is done, and to do that, you really need to understand exactly what's in there. You need to compute averages, medians, plot different things, and make sure that you understand the data set you're working with. Okay, another exercise that I'm putting out there. If you have issues, again, ask me for the results. I'll probably upload some of these snippets of code at some point once I believe that you've already tried it. Okay, so I will upload these snippets of code, but for the moment, please try to make the effort of trying to see whether this is something that you can do or not, because you'll be asked to do slightly more complicated things for your homeworks, so make sure that you understand how to do these small exercises that I put here. And try not to look at the solution, okay, before it. Okay, so you can also play around. What we've done was for the first quarter of 2012. You can play around with other quarters, okay, and try to compute other things. And make sure you fully understand the code that you're running. Make sure you fully understand the dataset and so on. Okay, so we are almost done with the CaBi dataset. Next, we'll look into how can we plot different types of data.